The mathematical problem that I've been asked to solve is in regards to marathon training, which can be seen on the screen. Question A states, draw a cumulative frequency curve for this data. The first step the student must take to solving this question is to draw a table very similar to the one that was given in the question, with the headings class interval and cumulative frequency. It is important to note that class intervals will remain the exact same as what they were in the question, although under cumulative frequency, the student will calculate the cumulative frequency, which is done by adding the frequency of the present point to the cumulative frequency of the previous point. As you can see, for the interval 10 to 15 kilometers, the cumulative frequency is 4 because there is no previous point. Although for the 15 to 20 kilometer interval, we plus the previous point, which is 4, to the present point, which is 6, which equals 10. And we do this for the 20 to 25 interval, the 25 to 30 kilometer interval, and the 30 to 35 kilometer interval, and the 35 to 40 kilometer interval. Once all the cumulative frequencies have been calculated, the student has to plot their data into a cumulative frequency curve. A response which isn't of an A level may not do the following. Give the graph a title, label the X and Y axis. They may not know that on the X axis is where the independent data goes, and the Y axis is where the dependent data goes. They may not have consistent increments on both the X and Y axis, and they may not even use a ruler. As you can see in the following response, the student has given the cumulative frequency curve an appropriate title, labelled both the X and Y axis accordingly. They have shown that the X axis is where the data is independent, which is the distance ran, and the Y axis is the dependent data, which is the cumulative frequency. It is also important the student uses the data that was calculated in the cumulative frequency table. Some students may make the mistake of using the frequency that was given to them in the question. Question 2 states, how many of the distances ran were less than 17 kilometers? To solve this question at a high standard, the student must have logic behind their response, rather than guessing where the 17 kilometer mark would be located. In order to calculate where the 17 kilometer mark would be, we're going to divide the distance between the increment by the distance the increment represents. So we're going to divide 2 centimeters by 5. This equaling 0.4. This means that every 0.4 centimeters is equal to 1 kilometer. Now the student is aware that every 0.4 centimeters is equal to 1 kilometer. They will go ahead and mark this on their graph. Once the student has located where the 17 kilometer mark is, they will use their ruler to determine where the 17 kilometer mark intersects with the line. As you can see, the student has identified that 5 marathon runners ran less than 17 kilometers. Question C. Draw a percentage cumulative frequency curve. For the student to successfully solve question C, they have to calculate the percentage cumulative frequency prior to plotting the data on the chart. An A-level response would organise the data into an appropriate table as such, with the headings class interval, cumulative frequency, and percentage cumulative frequency. The data within this table is very similar to the table that was used in question 1, with the addition of percentage cumulative frequency. The working of an A-level student will clearly provide a statement surrounding the justification and reasoning of how they calculated the percentage cumulative frequency. And as you can see, they have done this by writing it out as the percentage cumulative frequency equals the cumulative frequency divided by the total number within the data set multiplied by 100. Once the student has written this expression out, they can then apply it into their table like such. Now that the student has calculated the cumulative frequency in its percentage form, they will use these calculations to draw a curve graph because that is what the question is specifically asking for. The formatting of the graph is of utmost importance and must be completed in the following way in order for the student to achieve an A. The student has to give the graph an appropriate title, which they've done, label the X and Y axis correctly, taking into consideration that the cumulative frequency in its percentage form depends on the distances that the marathon runners ran, Have consistent increments on both the x and y axis, which the student has done correctly as their increments are consistently 2 centimeters. The student has to accurately plot and connect the percentage cumulative frequency on their curve graph, which again is evident that they have done. Question D, part 1. Find the 20th percentile. Firstly, to solve this question at an A standard, the student must show clear working out of how they obtained their answer, which should be done in the following way. Firstly, the student must know how to convert 20% into its fraction forms. Students may make the mistake of not doing this correctly. So 20 in its fraction form equals 20 divided by 100, which is equal to 0.2. To find the number of marathon runners that were in the race, we are going to refer back to the cumulative frequency table, where we see the total number of marathon runners is equal to 59. Now that we have 20% in its fraction form, we can go and multiply it by the total number of marathon runners, and we're going to write it as 20th percentile equals k% times the total number of marathon runners, where k equals 0.2 and the total number of marathon runners equals 59. This equals 11.8 runners, although how can we have 11.8 runners? So what we're going to do, we're going to round this up to 12. From this, we can gather that the 12th value in the data set is located in the interval of 20 to 25 kilometers. We can now calculate what the 12th value in the data set is equal to exactly. To complete this question, the student will draw a number line like such, with the lower end of the number line being equal to 20 and the greater end being equal to 25. Now that you can see this represents the interval. On the same number line, but underneath, there will be the value of 10, which represents the runners that ran less than 20 kilometers, and on the upper end, there will be the value of 23, which represents the runners that ran less than 25 kilometers. Now we are going to find our 20th percentile, which is calculated to be 12, and we are going to predict where this would be on the number line. As 12 is closer to 10, it will most likely be on the lower end of the number line. This meaning that the 20th percentile will be closer to the value of 20 kilometers than 25 kilometers. The first step we're going to do is find the difference between the 20th percentile and the lower end of the number line. Let's write the 20th percentile as P20. Now we want to find the width from P20 to 20. This is written as P20 take 20. The next step is to compare that to the width of the values underneath that. Therefore, it is 12 take 10. We will write this equation as P20 minus 20 divided by 12 minus 10. Then this is equal to the width of the whole number line, which is 25 minus 20 divided by 23 minus 10. Now we have our equation we can solve to find P20. It's easier to work out the right side, so we will do this first. We know that 25 minus 20 equals 5 and 23 minus 10 equals 13. Therefore, the right side now equals 5 divided by 13. Now we can start to solve the left-hand side. We can solve our denominator first, which is 12 minus 10, which equals 2. Now to get rid of this fraction, we can multiply by 2 on both sides. This now leaves us with P20 minus 20 equals 10 divided by 13. Now we can plus 20 on both sides, which will give us our P20 of 20.77 kilometers. This meaning that the 12th runner ran a total of 20.77 kilometers. Question D, part 2. Find the 0.8 quantile. Solving question D, part 2 is quite similar to the previous question. The only difference is we use the equation Q open bracket n plus 1 close bracket, where Q is equal to the quantile and n is equal to the total number in the data set. So we're going to solve this equation by using the following values. 0.8 open bracket 59 plus 1 close bracket. This is calculated to be 48. From this, we know by looking in our cumulative frequency table that 48 lies in the 30 to 35 kilometer interval. Therefore, we can calculate the exact value for the 0.8 quantile just like we did for the previous question. We start off by making the number line with 30 kilometers on the lower end of the spectrum and 35 kilometers on the higher end. This represents the interval. Now we put the value of the runners that ran less than 30 kilometers also on the lower end of the number line, which is equal to 39. We then put the value of the runners that ran less than 35 on the upper end of the number line, which is equal to 50. We know that the 0.8 quantile is 48, therefore it can be assumed that 48 is around this area and will be closer to the 35 kilometer mark. Now we continue on by creating our equation. Firstly, we want to find the width of our 0.8 quantile from the 30 kilometer mark and compare that to the corresponding values of 48 and 39. Therefore, our left side of the equation will read Q open bracket 0.8 close bracket minus 30 divided by 48 minus 39. Our right side of the equation will then be the whole width of the number line, which will be 35 minus 30 divided by 50 minus 39. To solve this, we will begin with the simplistic parts. Therefore, our equation will now read Q open bracket 0.8 close bracket minus 30 divided by 9 is equal to 5 divided by 11. From this, we multiply both sides by 9 to get Q open bracket 0.8 close bracket minus 30 equals 45 divided by 11. Lastly, we add 30 to both sides of the equation and we get the final answer of Q open bracket 0.8 close bracket equals 34.1. Therefore, our 0.8 quantile, which was found to be the 48th runner, ran a total of 34.1 kilometers.